Okay, so I posted the schedule for this week, I think last night sometime. So chapter 6 is the next on the schedule. But chapter 6 is really short, only 4 sections. Right? So we're going to take today and talk a little bit more about functions. Make sure we're up to date and everything's going well on functions. We're also going to introduce a concept, or the concept of reasoning. Well, we're going to try to think about how our functions are going to behave and what we can do to make them behave more effectively. Okay. So I want to start figuring out what I'm doing. That's a good thing. Okay. So we're going to start looking at the homework that was due, I guess, on Wednesday. The first one was the paint thing. It's kind of a weird problem. I did someday. Yeah, paint job estimator was one, and then the math quiz. Okay. So let's start with the paint job estimator. So again, we should have our main function for sure. Okay. And this one, I think it was assigned before we had talked about the value returning functions. So you don't have to do it that way. If you don't do a value returning function, you would have to print out all the results in the function. Okay, but I'm going to assume that it is a value returning function. Either way should work. Okay. So for this one, we're going to ask for the square feet, and we're going to ask for the price per gallon. Okay. So for this, we can just say it's a float input. That's going to be that. Square feet implied of the room, and we're going to enter input price per gallon paint. Okay, once we have those, we can have a function that's going to take in the square foot, and it's going to return how many gallons of paint you need. Okay, and I'm going to do something a little different here that we've talked about since, but you may not have known to do. I'm going to import the math because you have to round up, right? You can't return 1.5 gallons of paint, right? It's got to be a whole. You can't buy. Well, I guess you could, but we're going to assume whole gallons of paint. Okay, so we're going to get a function here for calculate the gallons. We can also use that to figure out the cost. So we'll start from there. So take the square foot. And again, this square foot variable lives in the main memory space. This one lives in the calculate gallons memory space. And they will initially have the same value, but they could change independently. So just keep that in mind. Okay. So down here, I'm just going to return. If I take, I'm going to use the math.stealing function, which is going to round up, okay, of the square foot divided by 112. And that's from the problem, that you get 1 gallon for every 112 square feet. So if I take that number and divide it by 112, if it divides evenly, it's going to return the number. But if it's any fraction, it's going to go ahead and return the whole gallon. Okay. So I think that makes more sense. Okay. But again, you didn't have to do that. So once I have that, I'll find the keyboard. Okay, so I can get, say, G for gallons. It's going to equal just calculate gallons, send it to square feet. Okay. And then I can get the hours worked. It's going to be the gallons times 8. Okay, because it says that for every 112 square feet takes 1 gallon of paint and takes 8 hours of labor. Okay, so that's what it's saying. Okay. And then once you have those, the calculations are pretty straightforward. Okay, you're just going to have to multiply the number of gallons times the gallons of paint, and then you multiply the number of hours times $35 an hour, list those separately, total them up, format them for currency, and you're good. Okay, that's going to take care of it. Okay, that's how I would do that for the questions there. Again, if you didn't do a returning function, you could do all of the calculations of printing in a separate function. That would be fine. Okay, look at the other one. Look at the random numbers. Okay, and there's not a whole lot. You kind of almost have to make up functions here. We have our main function, but let's do something else. And let's say we're going to get our random number in a function. It doesn't really change you much. It doesn't save you much. But so for this one, we're going to do a random.rand int between 111 and 999. Okay, remember with the rand int, it takes both endpoints, and we're assuming that this is going to do a 3-digit plus a 3-digit. Okay. So to call this one, then we would start by getting our n1, let's say, is going to be equal to get r, and n2, and be able to get r again. Okay, then I can print a tab, say, and then print n1, and then I can print a plus, see if this works, a plus and a tab, and n2, comma there. That looks right. And then we'll print a line underscore. See if that looks decent. Okay. Away, gotta move that. Looks decent. My line needs to be bigger, so I have a few more of these. Or actually, I could tab this. Looks are important. We programmed long enough now. We want them to. That looks good. Okay, I like that. Okay. Although, I think I would like dashes better, but that's okay. That's fine. Okay. So now I just have to go about getting the answer. I'm going to get the answer. The real answer is going to be equal to n1 plus n2. Their guess is going to be an int input. Going to use that for a prompt, and that may need a tab too. We'll see. So this looks okay. Yeah. Throw a tab in there, see what that does. Yeah, looks better, I guess. Don't love it still, but yeah, close enough. Anyway, once we've done that, then we just have to figure out if their guess is equal to the answer. So print right, else I'm going to print correct answer is answer. Okay, that should work. So if we get that, that should be equal to what, 1692? Is that right? My arithmetic skills are really bad. Oh, 1592. That was close. Okay. So if we get another one and it's actually correct, see, this is 1027, 1036. Is that right? Ooh, look at me doing that. It is funny that my arithmetic skills are horrible. I have a degree in math. Love mathematics. Arithmetic is not math. It's stuff that other people do in my world. So calculators are important. Okay. Questions about this one? Either the function, how we define up the functions, any of that stuff. You have other ways you could have gone, for sure. Okay. Okay. So there were 3 homework problems to do today. I will grade those at some point and we'll talk about them later. Okay. And I didn't say in the first class, but don't forget, as always, lab on Zoom tomorrow. Okay. So the things I want to talk about with functions, just to make sure that we're getting it correct here, is the idea of thinking more deeply about what's happening inside of our functions. Okay. So what we've done so far, we've written the functions, we've called the functions, so we know what we're doing. Okay. We're totally in control. But we talked about modules last time, and it's probably not the case in your career that you're going to always be the one writing your own functions. Okay. So it's not sufficient to do a validation loop inside of your main program. You need to do that always. You also want to make sure that your function does not take any input that is not correct. Okay. So we can do that in a couple of ways. We already know how to do, and again, I don't think I would do a validation loop. That's what I would do in the main. I would just return and not do anything if the input's wrong. Okay. It's not really the responsibility of the function to do the input. Okay. So let's take a look at something we've done before on the prime function. Okay. So it's going to take some number, whatever it is. Okay. And we can do for C in range. Yes.
Every time I do it, it's like it says name random is not defined.
You probably have to. Did you import random? Yeah, I'm not sure then. We can take a look at it after class. Yeah, it's random.randint.
Okay.
That could be it. Yeah, that's a good call. Okay, so it's going to be in the range here from 2 is where we want to start up to n, which goes up to n minus 1, which is what we want. Okay. So when I first started doing this, I thought what we did before, and I had a variable for is prime, but you don't need that. Okay, we're just going to return either, this is a Boolean function, returns either true or false. Okay, so in this case, if we go through, we're going to go through those numbers. We're going to say if n mod c is equal to 0. Okay, which is going to mean that c is a factor of n, therefore not prime. So we're going to return false at that point. Okay. If it's ever the case that we're at that line, let me turn on line numbers we talked about. If we ever make it to line 12, it means it's because we found a factor between 2 and n minus 1, which means the number's not prime. Okay. Now, mathematically, we don't have to go all the way up to n, but it's not going to hurt to do that. Okay. So if this isn't the case, then by the time we're done with all of these numbers, so that's where I'm at now on line 13. If I make it to here, it means that I went from 2 to n minus 1 and found no factors. So at this point, I can return a true. Okay. And we can test this out to see if it works. Here, we could do a print is prime, something we know is prime, 7. And we can print is prime, say something that is not 124. Okay. So this should give us a true false. And it does. Okay. So this is working. But it's not bulletproof. We could send it things that are not going to work for us. Okay. So, for example, we need to 0 is weird when it comes to prime numbers. We don't really want to mess with 0. Okay. 1 is weird too. We don't really want to mess with 1. So we want the numbers here to be 2 or greater. We also don't want negative numbers. Negative numbers can be prime, as far as I know. I'm going to look that up. It's an interesting theoretical question to think about. But certainly a negative number is not going to work in the way we have our loop structure. Okay, so we have to go the other way. So in looking at the preconditions, this is what we're going to call this. So the preconditions are as follows. Okay, n has to be greater than or equal to, we could say, greater than or equal to 2, and n has to be an int. It's not an integer. Weird things happen. Okay, Then when we look at our post conditions, okay, it's going to return true if prime and false otherwise. So there's not really much to check here. It can't go out of bounds, okay? Because there's no other way for it to return. We only have two return statements. One returns false, one returns true. So I'm not really worried about, in this case, I'm not worried about anything going wrong, okay? And again, some people were still unclear on this. If it hits line 20, whether it's the first, so with 124, let's look at 124, what happens, okay? 124, the first line to execute is 28. Okay, so they're going to go to 3, it's going to go to 4, that's all it's at. But so we go to 5. When it goes to 5, it goes to 8. It's going to skip the comments down to 16. The first value of C is going to be 2. It's going to take n mod C, or 124 mod 2, which is 0. So at that point, that is true. So it's going to skip these comments, hit this, and go back to line 6. It's done. Okay. In the other case, in 7, when it gets to here, okay, it's going to be equal to 2. This isn't true, so it's going to loop here, loop back around. Do 3, 4, 5, 6. Now it's done. Now it's here. Now it returns 2. Okay. The first return it hits, it's gone immediately. Okay. Does that make sense? Okay, so now let's worry about our preconditions here. So for the first one, okay, we're going to say if n, what's an error condition here? Okay, if it is less than 2. Okay, we're going to print. Must be 2 or higher. And we're going to return. We may be able just to do a return, but that may mess things up. So I'm going to return false, but I'm not happy about it. So think about that a little bit more. Okay. And for the second one, I think it was in this class, I tried to figure out how to use the type. Remember the type of a variable, it's going to return the type of that variable, whether it's an int or not. I wanted to use that in if statement, and it was ugly. It didn't work like I expected. Okay. Turns out, as I was doing some research, there's a new function, not the book, but it's a better one called isInstance. IsInstance takes an object and a type, and it's going to return true or false. Okay, so what I can do here is this. I can say if isInstance in int, actually if not, isInstance in int. And then I can return, or I can print the int. You should do better error messages than I do. And again, we're going to return false. Okay. So now if I do here like a -7, should give me the first error message. If I return 124.3, it should do the second error message. So let's see. Okay. So it's going to print those error messages. It's going to give me the false. Okay. So all that should be good. Now I don't, yes.
So this instance,
it gives you a false. Okay. Let's do some examples over here. So if I do x is equal to 5, I can do isInstance x int returns a true. IsInstance x float returns something. Oh, that's spelled right. IsInstance x float going to return false. Okay. So that's how we're going to use that. You should use this a lot. This is one of those things we know it, now we're going to use it, right? Whenever you need to check for that. Okay. It tests to see if x is an instance of int or float or double. We don't do that, or string or whatever. It's going to return true or false. Okay. So over here, I'm going to test. Is it an integer? Is what this is saying. If it's not, we're going to print there's an error. Okay. But I don't like that we're returning a false here, which is an okay false, and 2 falses when there's an error condition. Okay. So I would go ahead and have this return more than one variable. Okay, so I would have it return, say, false -99 to flag if there's an error. That's a -99. And then down here, we can return a false with 0. Computer science, 0 usually means it's okay. This is true with 0. Okay. And all that's fine, but over here, I would have to make sure I do something like P for the prime, E for the error is equal to that. And I could do P for whether it's prime or not, E for the error there. And that would allow me to capture. So let's say there's one that's correct and one that's not. Okay. And then if I want to print P and E, that should give some more value back. Okay. Why doesn't it like that? 'Cause I'm returning. Oh yeah, you are correct. It's good to have a room full of people. So it's like, oh, there's no P. Why am I putting P? Why is there even a P there? That's what I want. Yeah, P's totally in the wrong place. Okay, now it makes more sense. Now, okay. So in the first case, it's true that it's a prime, which is good. And the second one we're saying must be an int and then returns the false with that -99. Okay, so I could even do something in both these cases. Like if E is equal to -99, print error. But, okay, so we just have some more control. Okay. Then if not, P is whether or not it's prime. So something to think about on that. Okay. Questions about this? How this works? Okay. So the next thing I want, this is something I want you guys to do. I'm going to do a group project or in-class project. I want you to create a function called divide. And that function is going to return 2 parts. It's going to return the whole number when you divide one by the other. Okay, so for example, if I give you 8 and 3, let's say. So if I do 8, remember for integer division, it's // 8//3 is 2. Okay. 8 mod 3 is 2 as well, which that's a weird number, but that's what I want. I want the whole number divisor and I want the remainder. So that's what I want to return. Okay. So we'll have our define here for divide. I take 2 numbers and 1 and then 2. We're going to return the what do they call it? The dividend? Seems wrong. Maybe it is. Dividend and remainder. The integer dividend. And the remainder. Okay. So let's think about preconditions here. What's going to cause us trouble? Our negative numbers problem with division? Yeah, should be okay. What will cause us trouble? 0. Okay. We have one issue that we want these to be ints. We can't do integer division if there are no integers. Okay, so the preconditions are that it must both keys. There they are. Must be integers, and that n2 cannot be 0. Okay. So let's think about post conditions. And you don't know how to do this yet, but I'll show you when I come back after I give you some time to work on this. That's when you're working the preconditions. When we return our answers, so we're going to return. What about D? What do we know about? No, sorry, not D. So we're going to return the D and the R. What about D? What must be true about D? Do you know anything about D? Not much, really. I mean, depending on what's going on. If we have positive integers, we may know. Well, no, we do. We know that we should know that D is at most n1, right? There's no way to divide a number by something and make it be bigger. It's always going to be small. Okay. At least I think that's true. If you think of a counterexample, let me know. Let's be at least n1. Okay. What about R? What's the range of R going to be for a remainder? If I'm dividing by 15, what can R be? It could be 0, right? If it's 15, it's 0. The worst it could be on a remainder is 14, 0 through 14. Okay. So R is going to be between 0 and n2 minus 1. Okay. So we're going to look at those post conditions in a minute. Okay. Yes. You still just get a decimal. Okay. But I don't think we want to do that. I think we want to. When you do the integer division, I don't know if that. Well, let's try that. That's an interesting question. So what if I divide 8.2 integer division 3.4? Yeah, it works, but that's really not what we're looking for. Okay. So we're going to make the decision that that's not what we want. Okay. So I'm going to give you about 10 minutes. I'm going to go away. I'll come back in 10 minutes. And I want you can work with other people if you want, but I want you to get this working where you implement this function and make your main work. My main no longer works. Okay. You don't have to ask for input if you want. You can just force it. But I want you to do those preconditions. Okay, make sure the preconditions work. And then when I come back, we'll talk about the post conditions. Okay. Real quick here. The D is going to be equal to n1//2, and R is going to be equal to n1 mod 2, and then we're going to return, in this case, D and R. Okay. So I'm going to pause the recording here. Okay, thanks for that. Okay, so if it's not the case that n1, this instance, n1 int, or this instance n2 int, either of those, we're going to, let's say, return a -99 is our error code. Okay. Also say if n2 is equal to 0, and you probably would want to print an error message there, let you know what's going on. Okay. Then for the post conditions, there's a new concept here, and it's the assert statement. Okay. And assert's going to come in handy come Friday when we talk about exceptions. So if I have x is equal to 6, I can assert some condition. I can assert that x is greater than 0. If it's true, nothing happens. Totally ignores it. Okay. But if it's false, it's going to throw an error. Okay. So unlike before, we're trying to avoid errors. This is going to force an error. Okay. And we're going to learn on Friday how to deal with that error. Okay. So that's kind of where we're at. So for these conditions down here, I could say if D, okay, no, that's at most, right? That's not at least, at most. Okay, so if D is greater than N1, okay, so not if, I want to assert that. And the assert also allows for a message. Okay, dividend messed up. We could do something better than that, but that would be the problem. Okay. And then for this one, we can assert that R is greater than 0 and N2, no, yeah, and R is less than N2 minus 1. Okay, then again, you want to do something with that to be able to catch that error. Okay. But that's how we're going to assure the post conditions is with an assert statement. Okay. So that's it for today. If you have questions on this, putting up right now. If not, on tomorrow we'll have lab, and we'll do something with functions again. Wednesday, we'll start talking about files. We're going to be able to save our results to a file. And then on Friday, we'll finish up files and talk about exceptions. An exception is something unexpected that happens during the execution of your program. Okay? Any questions about anything? No homework for today, but keep up on your other homework.